Recording in progress.
All right, thank you. All right. Good evening, everybody. I hope you can hear me okay. It's an honor to be here, and I hope you're all enjoying your time in Vermont. I'm a relatively recent transplant, moved up here several years ago from Boston, and it was nice that Jennifer just mentioned you be in Thetford tomorrow, because that's actually where I live and where Soil for Climate, a nonprofit organization I co-founded with my colleague Seth Itzkan, is based. If this is a subject that appeals to you, that is regenerative agriculture as a climate solution, I'd encourage you to check us out on social media. We have about 35,000 members in our Facebook group from more than 100 countries around the world. And it's been really exciting over the last several years just to see the explosive rise in interest in this topic. A little bit about myself. I never thought I would have anything to do with farming. My grandfather was a farmer. He passed away when I was a young boy, raised peaches and apples, and had some animals on his farm outside of Boston. I went off to study chemistry because I thought I saw the world changing environmentally in a way that was undesirable. And we're to the point when I was 10 years old, 1970, it's when the first Earth Day was held. And up to that point, I thought about environmental problems as basically being either like litter or maybe air pollution and smog. These are things that I'd heard of. But right around the time of the first Earth Day, there was a lake, Cuyahoga in Ohio, that caught on fire. And there were flames that 80 feet high coming out of a lake. And when I began to see things like that, it occurred to me that, oh my gosh, this pollution thing is way bigger, and way worse than what I could have imagined at the time. So I studied chemistry. I worked in environmental chemistry labs and so forth. In 1989, I read Bill McKibben's book. Bill McKibben's name may be familiar to some of you. He's based at Middlebury College here in Vermont. He wrote what's considered the first book for lay audience on climate change in 1989, called The End of Nature, which is a pretty sobering title, frankly, and it's a pretty sobering read. One of the points he makes is that many of us still think that there are pristine parts of nature if we go into the woods and so on. But among the other facts that he shares in the book is you can go anywhere in the world today, literally, take a water sample, snow sample, soil sample, air sample, whatever, and you will find, if you research it in a laboratory, traces of the human element. So essentially, humans have spread ourselves and our technology all over the world. And one of the greatest challenges that I see of my generation, your generation, those following in our footsteps, will be to clean up the planet and heal it as best we can to help not only assure our own future, but also one for all the wildlife and all the creatures that we're blessed to share this planet with. Okay, so that's by way of introduction. As we begin to think about the ecosystem and the environment, and let's see, hang on one second, please. I'd show from the beginning. Okay, this should work now. All right, when we think about ecology, it's very, or environmental solutions, it's very important to think in as whole of a picture as we can. So in other words, the oceans are interacting with the continents and with the atmosphere and so on. Nothing is isolated, as John Muir, the naturalist, would say. Everything is connected. So here's a rainforest scene. And it's a little unclear as to exactly what's going on. Is this rain that's falling into the forest, or is it water vapor coming up off the trees? And in fact, it's probably both forces are in play here, or both processes are in play. And this is an example of a cycle. Most things in nature work as a cycle. We have the energy coming from the sun, and then on Earth, we have water cycles and we have nutrient cycles. And understanding how they operate can give us important clues in terms of how do we go about healing them. This was an exhibit that was at the National Botanical Gardens several years ago now, but it's a cutaway showing what a prairie actually looks like when you see grasses that may be 5 or 6 feet tall. The roots in many cases will go down almost twice as far. You can see some of them have actually been looped around and tied back up again, so that when you look out over a pasture, just like when you look at a tree, you only see the part above the ground. And in many cases, what's going on below the ground is much more involved and much more biologically active even than what we can see visually. One of the greatest problems that humanity is dealing with today is soil erosion. In this case, in this photo, it's from New Mexico in 1957, there are 5 feet of soil that have gone missing. And this has happened only in the last 150 years or so. This is an incredibly recent phenomenon. Why did this happen? And what's responsible for it? We'll be talking a little bit more about that here. This is a shot of a national park, I think Arizona. I'm not exactly sure of the location, but again, you can see tremendous amounts of erosion. And if you look, there is some sort of withered, technically, it would be called oxidized grass plants here. They're kind of like ghosts or remnants from an ecosystem. This tells you that not all that long ago, this was a pretty healthy ecosystem with thriving plants. Again, why is it dying? Okay, and it's not by any means just a US problem. Back in 2007, David Montgomery, who's a geologist, technically a geomorphologist studying the shape of the land, wrote a book asking if we're running out of soil, direct erosion of civilizations. He describes how more than 20 civilizations throughout history failed when their land became so degraded, basically the soil turned into sand, that they could no longer feed their populations. And given what I have been learning about regenerative agriculture, I kept, as I was reading this book, I kept waiting for, well, when does he talk about, all the great farming practices that can restore the land and bring back the health of the soil, which he never did. And it was, I come to find out many years later, it's because he didn't know, as one of the world experts on erosion, he didn't know that it was possible to stop these harmful processes and actually begin to bring the life back. And if I can just have a little detour here, David's wife is a biologist, Ann Bickley. They've co-authored a couple of books together. And when this book turned out to be very successful, David won I think it was a $500,000 grant from the MacArthur Foundation. You may have heard the term MacArthur Genius or MacArthur Fellow. And so he and his wife decided to buy a home up in Seattle. And his wife, being a biologist, was an avid gardener. And David told, in the telling of the story, he explains that when we got the house, we went in, we had the wiring inspected, the plumbing inspected, all the normal things that you would do, but they never did a soil test pit in the backyard. And after they bought the house and moved in, David discovered to his horror that the back of the house, backyard was basically a clay pit where very little, if anything, would grow. So he felt very dejected. And he said, here I am, I've dug soil pits all over the world. And it didn't occur to me to dig one in the backyard of this house that we were buying. So he went to tell his wife very dejectedly, honey, I'm sorry, but you're not going to have your garden here that you imagined. And she said, well, we'll see about that. And being in Seattle, there are many coffee shops in the area. So she went around to all of them and said, give me all your spent coffee beans. Anytime she saw a landscape crew in the neighborhood, she'd say, leave all your chippings or any debris, on our driveway, we'll take care of it. There's a zoo, a local zoo in Seattle that has a product called Zoo Doo, which is basically all the poop from all the different animals at the zoo. So they collected all that, and just feverishly, she went to work layering down all this compost on the soil. And within a relatively short period of time, David was astonished to see, first of all, that the compost seemed to be disappearing almost overnight. And to the point where he was wondering, are there like compost thieves? Is somebody coming around and like grabbing our poop and our compost? Like that didn't really make sense. But of course, what was going on is that the constant application of organic matter was allowing the soil health to return. So the bugs were beginning to feed, the soil was getting much more active, much more diverse. Within a couple of years, David was astonished to see that there were a couple of inches of new soil in his backyard. And his wife was creating this incredibly beautiful garden. And this went directly against everything David had been telling his students for decades. And then he realized, oh my gosh, I've got to look into this. So he then went on to research regenerative farmers all over the world and put out a new book back in 2017 called Growing a Revolution. Anyway, that's just kind of an aside, but so soil degradation goes on all over the world. It's kind of interesting to see the places that it doesn't. It tends to be the forests in some of the wettest areas of the world, but typically in low rainfall areas, and more importantly, in areas that tend to get rainfall seasonally. Many parts of the world, like New England or Western Europe, will get rain every month of the year, or island countries for that matter. There's always humidity in the air. If there's humidity in the air, then that means that the soil always has moisture in it. So even if around here, if you take a piece of land and strip it bare, guaranteed something is going to come up the next growing season because the soil stays alive because it's always moist. There are many parts of the world where, including in the western part of the US, where typically the rain comes only over a several-month period, and you might get 6 months or 8 months of a dry stretch. Places like that are very, very prone to soil degradation. And most ecologists today, if you ask them, just like David thought, will tell you, well, nothing can be done with that land. It's gone past the point of no return. This is something I hear quite often. But in fact, now, thankfully, there are ways of turning this around. When we have soil loss, not only is it soil degradation and erosion and so forth, but degraded soil can no longer hold as much water. So it's no surprise that some of the most politically turbulent regions of the world where we see the most conflict is often in areas where the rainfall is quite low and where the soil has become so degraded that it sets up the conditions in which political unrest can occur, like starvation, for example, migration, and so on. I'm going to talk now a little bit about I won't spend a lot of time on this, but the historical roots of climate change. How do we begin to learn about it? There are a couple of scientists here. I mean to update this slide. John Tyndall is credited with being the first to discover that CO2 can actually trap heat or block heat. Turned out Eunice Foote, a female scientist, actually did the work before John. He probably learned about it from her. He's the one who historically gets the credit, so I apologize that slide is somewhat outdated there. Back in 1958, during the International Geophysical Year, which was this global scientific cooperative effort among all the nations of the world, it was pretty remarkable, actually, to collect data on the planet, as many different physical phenomena as we could, to really begin to get a global conception of how the world was, much more rigorous detail in understanding what the different processes are, the environmental and weather processes and so on. Charles David Keeling was a graduate student who invented a way to measure carbon dioxide in the atmosphere several orders of magnitude better than had ever been possible before. Scientists always had a rough idea of what that number was, but it would vary somewhat depending on if you were measuring it downwind, say from a highway, where the number might be higher than what's actually in the air, or if you measure it in a forest where the trees are absorbing a lot of the carbon dioxide, the number might be lower. So Charles David Keeling's graduate advisor recommended that he go out to Hawaii, to Mauna Loa, in the middle of the ocean, where presumably the air was being mixed very well. And there was an astronomical observatory, it's still there at the top of the mountain. So the infrastructure was there, the electricity, the roads, and so forth. So it was an easy matter to begin measuring, which he did. And it was very quickly realized, just within a couple of years, by the early 1960s, that in fact the carbon dioxide level was steadily increasing. At the time, the scientific view was, well, the world is so big, the oceans are so big, there's no way that humans, we're so puny, can be influencing the global environment. In fact, Keeling, when he went back, shortly after making his first measurements, was calibrating his instruments, and he kept noticing the reading was a little higher. He's like, no, this can't be right. It couldn't have gone up. But sure enough, it has gone up, and it's gone up every year since then. And we know that carbon dioxide traps heat in. Although one of the things that I've been interested to learn is carbon dioxide, of course, is not the only force responsible for causing the planet to warm. Water vapor, in fact, is even has a more powerful influence than carbon dioxide, which isn't to say CO2 is not important, but also land degradation. If you've ever had the experience of walking from a desert into a forest, or from a forest out into a beach or something like that, you notice immediately the dramatic change in temperature. When you go in a forest, it's so much cooler. Well, why is that? And it's not just from the shade, of course, but it's also because the trees are all, they all have a process called evapotranspiration, where there's water being evaporated off the plants of every tree, every plant that you can see. And that evaporation process draws heat out of the air, so it feels cooler. So the more greenery you can put into a city, for example, the cooler the average temperatures will be in that city. When the water vapor goes off into the upper atmosphere and it condenses out into rain, at that point, the heat is released. But now, at least it's not at surface level, it's much higher in the atmosphere and has a greater chance of escaping the planet. So,
I had a question.
yes, sir.
You said that they did that test out in the ocean.
Yes.
I was wondering, because I was studying like soil carbon sequestration. So I was wondering if that wouldn't that be higher because it is away from the soil, that area?
That's a great question. There's so much mixing in the air currents that although you can, in fact, there's NASA technology, I don't have a clip of it here, but it allows you to see like carbon dioxide levels changing around the world. So I think for that reason, you're right. I think you would get artificially a higher level because the soils would be drawing it down.
Yeah.
When you watch these time lapse of the NASA clips, it's pretty amazing. You can actually see carbon dioxide being sucked in as all the plants are growing in the northern hemisphere. In fact, what I should mention here is you can see that this line is not a steady, smooth line. In fact, it's a sawtooth. And what this represents is that each spring, when all the, at least in the northern hemisphere, which if you look at a global map, you can see most of the land is in the global north. During the spring in the global north, all the plants begin growing, all the leaves begin growing, that pulls carbon out of the atmosphere. That's what we're seeing going on right here. And then in the fall, when all the leaves begin to decompose and all the plants get eaten up by bugs and ruminants and other creatures, then the carbon dioxide is liberated and goes back up into the air. So that's the sawtooth effect that we see there. Yes, sir.
So in a tropical environment, if that same test was begun in a tropical environment where there are not seasons, because in our environment we have a lot of rotten fruit, a lot of waste of fruit, then that's when it will go up higher because of that. Or what will be the reason for the jagged surge? Yeah.
It's because of the amount of mixing that goes on all over the world. So even though you're measuring in a local area and it's possible it may be a little bit higher because of what's going on, say in your backyard or on your farm, that sort of thing. In fact, there are very sophisticated pieces of equipment called eddy flux towers that can measure in real time how much carbon dioxide and water vapor is either coming up or going down into the ground and so forth. That it's much more sophisticated. For most practical purposes, the air is being mixed everywhere, so it's roughly homogeneous worldwide. This is just showing that the CO2 levels have continued to rise historically since the 1850s, or this map shows 1900. But what's interesting, this is from a Scientific American paper back in 2006. William Rudiman came up with a hypothesis based on looking at ice core samples. And I'm not sure if you're familiar with this, but scientists for at least since the 1960s and 70s have been drilling ice core samples, basically as deep as a mile, or in some cases 2 miles deep. So they'll bring a drilling rig, solar powered, so there's no fumes from diesel generators or that sort of thing. They'll drill down, take out about an ice core sample about the size of a baseball bat, something like that, put it into a freezer. Then they take the next section, freeze that, and so forth. And then back in the laboratory, by melting certain sections of that ice core, they can find air bubbles that have trapped what the atmosphere was at that point in history. We have this data going back about 800,000 years now. And it's pretty amazing. And they find not only what the concentrations of different gases are for that whole period, but also you can find things like pollen from plants that were in the area at that time. You can find remnants of the Iron Age and the Bronze Age from metal particles that are trapped in the ice. Like if there's a volcanic eruption, you can find that in the ice core as well. So anyway, by studying these ice core records, William Rudiman said, anthropogenic climate change, humans began tampering with the atmosphere, not just in the 1850s during the fossil fuel boom, with coal production and so on, but actually about 10,000 years ago. Although we were pretty small in numbers at that time, we still had a measurable effect on the environmental record, by doing things such as burning, widespread burning, deforestation, and then later, starting 3,000 or more than that, the Egyptian timeframe, 4,000 to 5,000 years ago, with plowing. And now we understand with mismanaged grazing, improper grazing. And then, of course, more just in the last couple hundred years, with the industrialization of agriculture, with more plowing and mechanized systems, we had much greater impact. And of course, the use of chemical fertilizers and pesticides, soil erosion happened even faster. So interestingly, when you erode soil, that releases carbon dioxide into the air. This is something that's been going on for thousands and thousands of years. And back in the early 1970s, a scientist put out this paper. Basically, he asked the question, when did the carbon dioxide from fossil fuels surpass that from the soil erosion? And he calculated it was probably sometime in the 1960s. So if you think back historically, World War II, all the ships and the trains and the aircraft carriers, just massive amounts of energy being burned, still was not putting up more carbon dioxide than soil. Okay, so soil has been a contributor of carbon dioxide to the atmosphere for a long, long, long time. And this is just a quick graph showing that, as you're no doubt aware, land temperatures, ocean temperatures continue to rise. We know a lot about the ocean now because there's a system of thousands of undersea probes that have only been around for about a decade or so. Every few days, the probes will drop down, measure salinity, pH, temperature, and so on. And then after a while underwater, they pop up, transmit to a satellite. So we've been able to develop this 3D map of what's happening in the world's oceans. And one of the things that we've learned is that most of the heat being generated by the warming that our planet is experiencing is in fact going into the oceans, with only a very small amount of it going into the land in terms of melting glaciers and all of the other effects that we're seeing, the more powerful hurricanes. Most of the heat is going into the ocean. And when it goes into the ocean, it can stay there for thousands of years. One of the things we see from oceans warming is just the expansion of water. So we've had sea level rise that's continuing. With this paper, Ilko Rollins estimated that if we can keep the carbon dioxide level at about what it is today, then gradually the ocean, he expects, will rise up to about 30 feet above what the level is now. And for that reason, he's saying it's incredibly important to reduce the atmospheric CO2 levels similar to what it was in pre-industrial times. So he's saying here, we've got to get that excess carbon dioxide out of the air. This shows warming is happening even faster at the poles, reasons I won't go into. There's been a lot of ice melt. We didn't even know how severe the ice melting was, partly because when the nuclear submarines would travel underneath the ice, they could measure using radar from below. They could see how deep the ice was. But this information was considered a national security information, so it was not released to the public until Vice President Al Gore was in the White House, and he insisted that the data be released. Because when you take pictures, you can see the extent, but you don't know how thick it is. And of course, the thickness tells you so much more about the situation. This book I'll just mention quickly in passing, Under a Green Sky. This researcher looked historically at where all the extinctions had been, and he noticed that all of them had occurred at times of high carbon dioxide levels in the atmosphere. Is it the high carbon dioxide that causes the extinction? No, but what the high CO2 levels can do is disrupt, in particular, ocean circulation patterns. And if the ocean begins to die, which he theorizes is what happened in the past, then it can, the ocean, from all the rotting plant life and animal life, can release hydrogen sulfide gas, which is extremely toxic, and it can actually end up turning the sky green. And part of the reason to support his hypothesis is that during these different extinction events, it was the animals that were located near the oceans that died off at the highest rates. Those who were farther away from the oceans inland tended to have better survival. We know that there's a pretty strong correlation, again, not causation, but correlation between the temperature and the carbon dioxide level. We can see that as the CO2 levels go up, the heat also goes up. the temperature also goes up. And it's not a perfect match, but it's a pretty compelling match. This gives an outline of how several of the major greenhouse warming gases have gone up since the year, this would have been 0 AD, and up into the modern times. It's really been in the last couple hundred years, 100 years or so, when things are really starting to go up the charts. Susan Solomon, an MIT professor and also co-chair of the Intergovernmental Panel on Climate Change, put out a paper about a dozen years ago saying that even if we capped all emissions now, we could expect all the warming in the ocean rise to continue for possibly 1,000 years in the future. She called it irreversible, which is a pretty powerful word to put into a scientific paper. The following year, the Intergovernmental Panel on Climate Change said, I'll read it, I don't know if everyone can see it, but it says a large fraction of anthropogenic climate change resulting from CO2 emissions is irreversible, that's Susan Solomon's term, on a multi-century to millennial time scale, except in the case of a large net removal of CO2 from the atmosphere over a sustained period. So here we are, 11 years ago, the IPCC is saying we've got to get the carbon out of the air. The United Nations responded by saying the potential of land to hold carbon as a sink for greenhouse gases is unparalleled, right? Land is where it's at. It's the only place that we can possibly put this much carbon. You may have heard of different approaches, mostly technical approaches for dealing with climate change. There's a fellow, David Keith at Harvard, who's encouraging the spraying of sulfate particles in the upper atmosphere, basically having a fleet of business jets flying 24 hours a day for decades, maybe centuries, spraying this stuff to help reflect the sun. We could put sort of like giant mirrors in orbit. I mean, there were some pretty far-fetched, pretty crazy ideas. These all broadly fall into the category called geoengineering. Back in the 1980s, a French scientist came up with the term geotherapy, which personally I find very much more satisfying because you're talking about healing the planet, not trying to force it into a different direction. The book Project Drawdown lists all of these different things that can be done to reduce the amount of carbon dioxide in the atmosphere. Most of them involves efficiency. So you're putting up less. You're getting a car that gets more miles per gallon. Okay, well, you're still causing harm, but you're causing less harm. And this is the mindset that most climate activists, I think, are the trap that they've fallen into. And certainly I used to be in this position thinking, well, if we just all embrace efficiency, we can cut our emissions and that'll be enough to solve the problem. In fact, it's not. Just cutting emissions isn't good enough. We've, again, got to get the carbon out of the air. When emissions go into the atmosphere, this slide's a little outdated. We're up to around 11 billion tons of a year of carbon now, either from agriculture or from emissions, transportation, industry, et cetera. There are only 3 places that carbon can go. It can go into the ocean where it causes acidification, which is not a good thing. It can go into the atmosphere where it causes warming, not good. Or it can go back into the soil where, in fact, it's extremely beneficial. So soil, and I hope I'm making the case, is where we've got to get all the carbon from the excess carbon from the atmosphere. It's the only place feasibly that it can go. And this is an image showing what's called the soil food web, which is the interaction of life everywhere from a microscopic scale all the way up to the typical creatures, the bugs and so on that we see running around, and the mice and voles and so forth. And plant roots can, as I showed in the slide earlier, can extend deep underground. And the thing is, the way the carbon dioxide from the atmosphere gets into the soil is when plants grow during photosynthesis, they're taking carbon dioxide out of the air, and they're using that to make mostly sugar molecules. And then by putting them together as sort of like Lego building blocks, the carbon dioxide in the atmosphere is turned into the plant structure itself, the stalk, the leaves, the stem, the roots, and so forth. But interestingly, the plant does not keep a lot of these sugar molecules for itself. Instead, what the plants do is it pumps it out through their roots underground. The technical name for this is root exudates. I've been told that with a corn plant, I haven't done this yet, maybe it's not too late this year. But if you actually taste the roots of a corn plant, apparently they're extremely sweet. And you can think of maple syrup. Every spring, the maple tree is again oozing a lot of its excess sugars. It has so much that it comes out as a syrup. But every single plant is pumping these root exudates or these sugars into the ground. Why is the plant doing that? It's doing it to feed the life that lives in the soil. So all these bacteria and fungi that are living in the soil, doing all the hard work, the way they get fed is with the sugar syrup that is brought there by the plants. And so sure enough, let's see. There's a saying that water follows carbon. When you introduce more carbon into the soil, you're turning that soil into a sponge that can now hold much more water. In fact, you don't need to remember this, but for every 1% increase in soil organic matter, an acre of land will hold about, oh, thank you. About 20,000 more gallons of water. So a huge way to deal with the flooding and to make farms more resilient is to improve the health of the soil. There's a farmer that's become pretty well known out of North Dakota named Gabe Brown. He's written a book on regenerative agriculture called Dirt to Soil. Some of his fields, he's improved the organic matter from 1% up to 6% or even higher. What that means is each acre of his field can hold an additional 100,000 gallons of water. And he's got like 5,000 acres. So 5,000 times 100,000. I mean, we're talking massive amounts of rainfall. And what it means in practical terms is that he's eliminated flooding on his farm. His neighbors' farms will still flood out. But whenever it rains in his place, all of the water gets sucked into the soil and it gets held there and it's released very slowly over time, the way nature intended. So dried up springs and brooks on his farm have come back to flow and so forth. So and eventually what will happen is the aquifers will become recharged. Okay. Yes.
There is supposedly like a higher level of like heavy metals in the soil now, right? How does that affect like the soil through web and plants and evaporation? Like how does it affect the whole thing?
Sure. If the metal is from contamination from like an industrial process or so on, there's something called phytoremediation. Certain plants will concentrate certain types of metals so they can be used to remove the excess metals from the soil. Fungi or mushrooms, mycoremediation, can also be used to break down not necessarily metals, but various organic chemicals that can otherwise be extremely hard to get rid of. So there are things that farmers can do intentionally to clean up sites. In fact, if I have time to get to it, I'll be talking about a cleanup of a mining site, actually, and how that was accomplished. So how do we improve the carbon in soil? There are different ways. Organic farming practices are, in general, in most parts of the world, all about improving soil health. I'm sorry to say one exception is in the United States, where hydroponic food is allowed to be sold as organic. It's the only country in the world where that's allowed. Okay, so you can buy berries, they're labeled organic, but they're from a bucket. In some cases, the bucket is sitting on a big sheet of plastic covering many acres, and yet it's labeled as organic. So it just seems to defy what the original vision was of those who wrote the original legislation. And I'm very proud to say that right in East Thetford East Thetford is the home base of what's called the Real Organic Project. And there are a number of farmers who were involved in setting up the original rules for the organic program who've been very upset over basically the way big business has come in and watered down the standards and so forth, that they've started something called the Real Organic Project. And I don't have a picture here of the label, but in the supermarket around here, you may see from time to time like a box of tomatoes or some blueberries or something that has this little sticker on it that says Real Organic. When you buy that product, that's your assurance, the label is your assurance that the product is being grown in a way that meets what most people think of when you think of organic. This is intercropping. So basically there are cover crops here, and this farmer is planting, instead of plowing the field, he's planting directly into the existing cover crop. So one of the goals is to disturb the soil as little as possible, either low till or no till. This is showing biochar, which is discovered in Brazil, where the farmers for thousands of years had been making a form of charcoal, a special type of charcoal, adding it to the soil and finding that it greatly improved fertility. It doesn't work like the way a normal fertilizer does. It's not adding nutrients, but it's adding structure to the soil, and it's providing basically a home for the microbes that live underground. And in practice, this is what it can look like. This was a friend from Cambridge who decided after flying, doing a trip to Europe, he decided to buy biochar, and he handed out to all his friends and neighbors and so forth to offset the emissions from his airplane travel. Okay, so for those of you who have not heard about Alan Savory, I'd like to introduce him to you at this point. Alan gave a TED Talk back in 2013 that went viral. I believe there are close to 10 million views now. Alan grew up in Rhodesia, which is today's Zimbabwe. As a young man, he studied ecology, and in his early 20s, he was put in charge of national parks. And he was very dismayed to see the amount of erosion that was happening in the parks. Based on everything he had learned in school, he was told, well, if you have too much erosion going on, then it's because of overgrazing, because there are too many animals. So Alan, to his great discredit, he says in his TED Talk, which I encourage people to watch, that he'll take this decision to his grave. But the decision was made to initiate a culling program to kill elephants. Okay, now this is pretty shocking, but what's even more shocking is that today there are conservation biologists that are advocating for killing of elephants, believing that the animals are causing the problem. Okay. What Alan realized was even after the program went ahead and many elephants were killed, the land kept getting worse. And he was like, my God, what have I done? All of my professors, all of them said, you've got to get rid of the animals. I've done that. And things have gotten far worse. So he made it as a life commitment to himself to figure out what is the cause of this desertification, what can be done to stop it and turn it around. This map shows areas of the world that are most prone to desertification, all the areas that are sort of tan and gray and so on. The green areas are, fortunately, because of the rainfall patterns, are not subject to desertification. But all the areas that are desertifying, they're all relatively low rainfall, and they're all grasslands. Grasslands are the largest ecosystem on the planet, larger than any forest or whatever. What we understand now is that grasslands co-evolved with massive numbers of animals, not just the bison, but pronghorn and zebra and moles and prairie dogs and so on. The amount of wildlife that used to exist on this planet is absolutely staggering. And one of the things Alan realized when he wanted to study ecology, they asked him at school when he went to register, you want to study plant ecology or animal ecology? And he said, well, I just want to study ecology, the way plants interact with the animals. And it's like, no, you've got to choose your career path. And that was one of his indications that, we're living in this world where everything is broken up into all these little fiefdoms of knowledge, where very often the biologists aren't talking to the chemists aren't talking to the physicists aren't talking to the, whoever, the meteorologists, people become so specialized that very often we lose sight of the connections that are drawing everything together. As an example of how important the ruminants are in creating soil or carbon in the soil, there are two graphs, one showing Australia, which has much lower levels of soil carbon than in Africa. And the reason is that the ungulates, of which ruminants are a category, just never evolved in Australia. So the soils just historically never got as rich as it did in parts of the world that had large amounts of animal interaction. This is a sort of an iconic photo. I don't know if any of you have seen it before. It's quite tragic, but there was a great buffalo kill-off that essentially as a way of controlling the native peoples of this country, to the point Andrew Jackson after the Civil War, sent the US Army in to help kill off all the bison. And when even that wasn't enough, bounties were put on were offered for every bison skull or buffalo skull that could be delivered. So this is a mountain of buffalo bones. And as a final insult, these bones were used to make fertilizer for one last time. So the bison, which had been providing fertilizer for literally tens of millions of years, were killed off, and then even their bones were used in the end.
A time where there was mass like cattle production also.
I'm sorry, mass what?
Was this during that time where there was a lot of cattle production and livestock production?
The livestock would have been moving in around that time. I mean, the reason the army was sent there to control the Native Americans and put them under reservation was to open up the land for some people call them settlers, I would call them the invaders, to come in to have farms and to have cattle grazing and so forth. So the buffalo genocide, the end of soil, and the beginning of desertification. This was a picture back in the 1930s. Many of us may have heard of the Dust Bowl, which led to some of the first soil legislation in the country. There are many parts out west that if you went out there today, you would still be seeing something like this. And the Dust Bowl, unfortunately, has not gone away. Here's Alan Savory speaking to a bunch of farmers and ranchers. And in the 1950s, there was a French scientist, André Voisin, who realized that if you group the livestock together and move them to a new spot every few days, then the land would come back. It's pretty much what pastoralists had been doing historically for thousands of years. And of course, the numbers of people were so small back in historic times that the land would have always have had a chance to come back to health before the animals were grazed again. And anyway, so this French scientist figured out you've got to keep the animals grouped together. In a typical grazing operation, you just put your cows out on the pasture, at least in America, and you forget about them. Okay, it's called continuous grazing. I call it laissez-faire grazing because you're basically, it's hands off. The cows can eat whatever they want, anytime they want. If that plant looks tasty, they might go over and keep eating it, every couple of days until the plant's dead. All right. And it's incredibly important that after the animals have grazed for a couple of days, you move them to that new spot and never go back to the original site until enough time has passed for the grasses to come back again. Now, this may sound pretty obvious, but believe it or not, it's considered highly controversial in the academic world right now for reasons that I won't go into, but there's a lot of misunderstandings, even in terminology and how the research is done and so forth. Anyway, Alan took Voisin's approach to the dry climates that he was familiar with back in Africa and tried to use it and realized it just wasn't good enough. He just wasn't getting the timing right. So he developed a much more nuanced and a sophisticated planning process to help farmers plan exactly to guarantee that the animals were going to be grazing in the right spot at the right time for the right reason. This is an example of a grass plant when a lot of people can understand overgrazing is a bad thing. If the plant gets eaten up too much, obviously that's not good for it. It turns out undergrazing or insufficient animal impact is also harmful. The reason for that is that grass plants have their growing tips. The part of the plant that needs to get sunlight in order for the new growth to happen is located down at ground level. So if that plant never gets grazed, it will shade itself to death. Something has to come along and remove the overburden of grass. In parts of the world where there aren't enough animals left to do the grazing, typically there are massive fires that are set, which has the advantage of allowing the grass plant to begin growing again. But there's a saying in Africa that you can't eat smoke. So it's always better to turn the grass into something that you can feed your family with instead of just sending it wafting up into the skies. So overgrazing is a human invention. There was no overgrazing until humans came along and began to interrupt these exquisitely tuned grazing patterns that had evolved over about 40 million years. Okay, so it might be worth just to say a minute here. What is overgrazing? Most scientists, if you ask them, will tell you, well, it means you have too many animals. Okay, so if you have a field that's being overgrazed, if you have 100 cows on it, reduce it down to 50. Problem solved. Well, it doesn't solve the problem. In fact, overgrazing occurs when a cow takes a bite or sheep, goat, whatever, takes a bite of a plant and then comes back to it a few days later, just when the new growth leaves are starting to come up, and takes a second chomp. Okay, that's really hard on the plant because now the plant's like, oh, wow, I just put all my energy into creating those growth leaves, and now I've got to send out more growth leaves. So then the cow, meanwhile, is looking at the plant saying, wow, new growth leaves coming in, which are very tasty. So it's going to go back and it's going to preferentially favor that plant. Overgrazing happens as a function of timing, not the number of animals. So you can have 1,000 animals, livestock, on the size of like a soccer pitch. And if they're only there for an hour or two, they're not going to hurt any of the plants. They'll graze everything down. It might even look like a mess, like when the bison came through in these enormous herds, thousands and thousands of animals. If you came upon a site right where they had just come through, it probably wasn't a nice thing to see. But if you come back in 3 months or 6 months after that, it looks like the Garden of Eden. This is how nature operates in terms of impact and then long periods of recovery, impact and then recovery. When you do conventional grazing, just putting the animals out and forget about them, you're completely ignoring that cycle. Now, how did nature manage this? In nature, anytime you had ruminants, grazing animals, you always had predators, typically wolves, around the outside. So the wolves would cause the grazers to always be in a pack. It would be suicide just to wander off somewhere and try to eat by yourself. It wouldn't happen. So the animals would all be grouped into a bunch. Meanwhile, the cows, of course, or whatever the grazing animal was, whether it was bison or moose or what have you, they'd all be pooping and peeing on their food. So they're not going to stay around there too long because no animal likes to eat food that's been soiled. So the herd would always keep moving in search of that fresh forage. It would never linger too long together in one spot, okay? So that the wolves are keeping the herds together and the repulsion to the dung is keeping that herd moving. That was nature's solution to prevent overgrazing. That's the genius of nature. Let's see. This is, again, just showing scenes from wildlife, how today we've learned how to use livestock as a proxy for the wild herds. Tragically, in many parts of the world, almost all the wild grazers, case in point, here in the US, the bison have been wiped out. Some people say, well, why don't we just introduce bison? Well, there used to be about 65 million bison. Estimates are that high. Today, there are only about 500,000. So roughly 1%. We just don't have enough bison to do the job right now. Fortunately, there are about 100 million cows in this country that if they weren't locked away in these big factory farms, and if they're out on the pasture being moved properly in a way that emulated nature, could take on this historical role that the bison have been doing. Our bison, should we have more bison? Absolutely. I had the honor and privilege of touring a bison ranch out in Colorado. Just magnificent creatures. And there were about a dozen of us being towed around this trailer. And I don't get to spend a lot of time on farms with animals. So when the trailer came, when the truck came to a stop, I began jumping down out of the trailer to basically go pet the bison. And the fellow who was leading the tour said, no, don't do that. They might look docile and beautiful, but they can be extremely skittish. So just the practicality of trying to replace, for example, livestock populations with bison would be so challenging because cows are, although they're not completely harmless, they can be so much easier to handle and to manage and so on. So these are some shots from, we work with some Maasai tribe in Kenya, and also do some work with agroforestry in Tanzania that I won't be getting into here. But here it's showing how the animals are kept in herd. And then at night, for protection, there are these temporary mobile corrals that are built with often they'll have like little strobe lights on top, and the lions will not jump in and attack the herd because they can't see what's on the other side. And the animals, like every night for a week, will be kept there overnight, and then during the day they're brought out to graze different areas. And after a week of the animals sleeping over here, this land will next season be used for crop production because the soil is incredibly fertile with all the concentrated manure and dung and trampling and so forth. Okay. This is an example of a grazing plan. So, understanding in advance, where do you want the animals? So if you have a certain type of, rare bird, let's say, that is going to be in this field at this time of year, or if there's a plant, a type of plant here that you're trying to encourage, you can think in advance strategically, okay, I don't want the animals here at that time, but I do want them over here. So just helping to understand that the animals will be in the right place at the right time for the right reason. And when you begin to heal the land back, then you can free people from having to receive aid and so forth. Instead, you're being able to restore rivers, bring the soil back to life, restore the native foods. I mean, the Maasai people that we work with, their traditional meal historically, their diet is meat, milk, and blood. And that's basically it. I mean, they may have some berries or spices and herbs and so on, but animal nutrition is core to their culture. These are examples of what happened when you do grazing properly, 2004, 2007, 2013. There's no planting going on here. There's no fertilization other than what the animals are leaving behind. There's no watering, no irrigation, just giving back to the land what it has been evolved over tens of millions of years to require. Here's another site that, again, just over a couple of years, this land that had probably lain like that for decades, maybe centuries, just a really terrible condition, was brought back in about a decade. This is a site in Mexico where the farmer had dug out, using a big bulldozer, this big watering hole that would fill up from the rain, and the animals would come there and drink. The arrows here to show a landmark in the background. This is what the site looks like today. It's almost mind-blowing. And sometimes people ask, well, where do the animals get their water now? And the thing is, the springs that had dried up have begun flowing again. So the animals can go and drink at the spring the way they used to for eons before that. In fact, there's far more water in this picture than there was in the preceding one. But now the water is in the form of the vegetation. It's being held in the giant soil sponge and so forth. And a couple of shots here from North America. This is a rancher, a fellow named Alejandro Carrillo, doing work in the Chihuahuan Desert, which stretches from Mexico into the southern US. This is what the site looked like in 2015, 2018, and 2021. So again, a lot of ecologists would say that's impossible, the evidence that I'm sharing with you. And you can go on a Google map, you can look, you can see it for yourself. It's not impossible. It is happening. And anyone concerned about the climate should understand that when you see a restored ecosystem, it means less carbon in the atmosphere. This is what I mentioned about the site cleanup. This was a mine site where acid had been poured over the hillside to extract all the last bits of gold or whatever other metals that they were trying to get out. And these land sites like this are notoriously difficult to restore because there's virtually no biology left in the soil at all. I mean, when you put acid into soil, it kills almost everything. Excuse me. And the mining company had an obligation before they could get a permit to do the mining. They had to agree that they were going to restore it back to some semblance, of good ecology. And they tried at first hydroseeding, spraying the seeds and the fertilizers up, the chemical fertilizers on the hill. That didn't work. And finally, what did work was bringing livestock up on the hill. They grazed them on the hillside. They brought in bales of hay so the cows would have something to eat. They grazed the hillside, and within a short time later, the grasses began growing. That brought bugs in, brought birds in following the bugs, and mammals in after the birds, and so on. So even in highly destroyed sites, proper animal impact can be very restorative. So just want to do a time check here.
8:14.
8:14. Okay. So this photo was taken in the Karoo in South Africa. It could be from Arizona, could be from China, large parts of the world. If anyone's interested in getting a copy of this photo, there's actually one on the back of my business card, which I brought a bunch of, if anybody would like to have one. So I have a couple of trick questions for the audience here. The first one is, what side of the fence here gets more rain? Exactly, I know, but sometimes people look at this picture and they're like, well, obviously it must be raining more on this side, and then they think, well, no, that can't be right. No, in fact, both sides are getting the same amount of rain, okay, so what's going on? Here's the second trick question. Which side has more animals grazing on it? Well, the left, because there's grass for them to eat, okay? So yes, there are far more animals on this side. So what happened here? Historically, if you could go back in your time machine, say 10,000, 5,000 years ago, what have you, it would have all been grassland. It would have looked like this side. But then grazing was brought in on both sides. Both sides became degraded, so it looked like a desert. This used to look like a desert. How was this brought back again? By moving the animals in a way that nature evolved. Okay, so we hear a lot, certainly I do, from many sources, including many environmentalists, climate scientists. You'll often hear eat less meat. And the first issue I have with that is, well, the environmental harm doesn't happen when you eat the meat. I mean, if you are going to eat meat, by the time the steak is sitting on your plate in front of you, the damage has already been done. Eating it doesn't cause, so the problem isn't the eating of it. So what does eat less meat really mean? It really means produce less meat, because it's during the production of meat that we know there are a lot of crops grown that are very harmful for the environment because of the cropping practices. Of course, cows have gotten a bad rap because of the methane generated by their guts and so forth. But when we begin to understand that the only reason we should produce less meat is because it's thought cows are inherently bad for the environment. But what this new research has been showing is, as a friend of mine coined the phrase, it's not the cow, it's the how. The issue is not the animal. There's no animal ever involved on this planet that is harmful to the ecosystem when it's interacting in a way that nature intended. It's not like cows historically were somehow good for the planet, and then one day they woke up and decided they were going to be harmful for the planet. It was the human intervention in ecological design that caused the problems that we're living with now. So I'm a huge proponent of nutritional freedom. I mean, I don't want anyone to tell me what I'm going to eat, and I don't think anyone else should tell anyone else what they should eat. But if we take a soil perspective or a nature perspective, we have to have the cows out on the landscape to heal the land. Whether you want to eat them or not, it's up to you. But we need to have them anyway, because large parts of the world will continue turning into desert, and the problem isn't going to get any better. So, on this side, we can see a future where families are able to grow, provide for themselves and for the future generations and so on. So I have a couple of other notes. I have a little video here that I'd like to show. I don't want to get too deeply into the technical stuff, but hopefully the volume's right here. To me, let me pause it just for a second. This is about a 3-minute clip from a National Geographic documentary. It came out, I think, in 2017. The fellow M. Sanjayan is a conservation biologist. Formerly, he was the head scientist of the Nature Conservancy. Today is the head of Conservation International. In this documentary series for National Geographic, who went around the world to study different farmers and ranchers who were using these practices essentially to bring nature back to life. And he's interviewing Alan Savory. And of course, Sanjayan himself was extremely skeptical that cows could be beneficial for nature. And this was his takeaway. And I just want to make sure the volume's up enough so everybody can hear it okay. All right, this should be good, I hope. All right.
Alan's results are spectacular. Despite recent drought, he has transformed this ranch from desert to rich grassland. Today, the grass holds the water, and streams that were dry for decades are flowing again. Amazingly, Alan already has more cows than most scientists would recommend, and he wants to add even more cows and more wildlife.
Right now, we are trying to double the animal numbers because we don't have enough animals to keep this grassland healthy.
So you want to put 1,000 cows on?
Absolutely.
And if you did that, and you did that for a few years, and I came back here, would I be able to notice the difference?
Yes, the land will be even healthier.
And more wildlife too?
Yes.
It's so counterintuitive. I just kind of want to shake. You know what I'm saying?
Yeah.
I mean, it really is.
Yes.
Until now, many scientists like myself believe that if animals were overgrazing, then the solution is pretty obvious: reduce their numbers. But Alan says what we really need in these habitats, in these natural areas that we think are being destroyed by elephants and other animals, we need more elephants, not less. We need more wildlife, not less, and far more than you can possibly imagine. Cows or wildlife, it actually may not matter that much. They just have to behave as if they've been herded by a dangerous predator. If Alan is right, then we may have to completely rethink life on the plains. The message is an extraordinarily powerful one, and it could be the best thing, the absolute best thing conservation has ever discovered. Alan's ideas have already inspired people all over the world. Increasingly, they are asking one question: can you truly have large numbers of animals, thriving grass-fed, and people all in the same place?
All right, I'll conclude my formal presentation there. Thank you for your attention and happy to take questions. Yes, sir.
I had a couple questions. Three up one. The first one is, I've noticed, in the talks that we've had around grassland pasture management, one thing that hasn't been discussed is that, you get less parasites in your animals when you prevent them from grazing closer to the ground because there's egg. So it's also a good method for controlling parasites within your.
Yes, something I've heard from different ranchers that I've spoken with, it's very common for example, for ivermectin to be used to kill any bugs in the guts of the animals and so on. And unfortunately, what it also does is it kills the dung beetles and other life in the soil. And when farmers begin moving their animals in a way that mimics or emulates how nature would do it, then they no longer have these sorts of problems with the parasites, partly for the reasons that you're describing. There are certain types of insects that will only live at a certain height on a grass plant. And so if you're bringing your cows into a pasture where the grass is, 3, 4, 5, a lush pasture, they're getting not only getting more nutrition from the plant and generating less methane because of the structure of the plant has less cellulose when it's in that part of the growth cycle, but they're avoiding the bugs that are down at ground level. So the reduction in the use of different pharmaceuticals and chemicals is a huge part of this.
Yeah, the second question was more about, just asking you a theoretical question. We hear about the effects of global warming and trying to do things to counteract that, but a lot of the global warming was caused by the expansion of the Western civilization.
Yes.
Europe and America exerting their power and increasing the wealth of their nations. And now we're asking poorer nations now to be the ones to take equal responsibility to fix it. And so you're asking them to not do the things that we did to become wealthy, advanced, powerful worlds. And what do you feel about that?
I agree with your framing entirely. There was just a report I heard recently about a shipwreck somewhere off the coast of South America. It's been being called the largest treasure haul ever, like $30 billion or something. And, of course, that was all stolen from the indigenous people in America, and the argument is, well, does it belong to France? Does it belong to England? It's like, I think that this is kind of missing the point. the wealthier parts of the world should be tripping over themselves to get support in terms of funding and training, everything that the poorest farmers of the world need in order to be able to help themselves work their way up and become more self-sufficient and more profitable and so on. So it pains me to see what the military expenditure is around the world, whereas what's going into actually improving the environment and making people's lives better is just a pittance compared to that. So I think priorities really need to change, and I hope it happens soon. You have another question?
Well, the other one was just, you mentioned about the 30-foot rise in sea level.
Yes.
Give us a time frame as to when that would happen.
I can check the paper. Typically, something like that would be measured in either centuries or millennia. It's not going to happen overnight. But if we don't do something to reduce the heating, either through land restoration, well, not just land restoration, but also cutting emissions and so on. If we don't get the excess carbon out of the air one way or the other, then the oceans will continue warming. And we have this little blip right now that if we can grab it, kind of stop it before it gets out of control, then we can prevent these sorts of things from happening. But the oceans are a tough one because they hold just massive amounts of heat. And it's kind of like trying to stop the proverbial, tanker ship or something. You've got so much inertia in a physical system. It's called hysteresis, but basically so much inertia in the system that stopping it is not going to be easy. I mean, what we're entering into now is going to be a process that will be going on possibly as long as there are humans. We've got to manage the world's ecosystems to get them back into some semblance of a working order, by giving nature what nature needs in order for it to be healthy, in order for ecosystems to thrive, and so on.
Question.
Yes.
The journalist that was interviewed, Alan Sabers in that National Geographic, he said to him that it's counterintuitive, it's theater. And I don't understand why he think that was counterintuitive for things to work better when it's working the way nature intended. Are we in denial? And really, is it man thinking that he's really smarter than nature and then realizing that he's destroyed it, it's kind of that destroyed it?
What I find is that many people who are close to nature and are doing these farming, they would agree entirely with you. Like, well, what's counterintuitive about that? But believe it or not, because of the reductionism within academia, it's just seen as a sort of this outrageous thought that cows could be beneficial and that having more cows could be even more beneficial. And some of it is the thinking that comes from there's a phrase, the tragedy of the commons. So if there's a forest that everybody's sharing, and if everybody's allowed to go in and cut, 1 or 2 trees a year, whatever, then the forest can continue growing, But some people say, oh, I can go in and take 10 trees, and that's not really going to hurt anyone. And then the next person says, well, they're taking 10, I'm going to take my 10. And suddenly you have a situation where the forest suddenly is gone. Like think about Easter Island, for example, just being completely deforested. And you can understand in the case of like trees or something that aren't, reproducing, but or take, an incredibly long period of time. But with cows, the way nature evolved, grassland needs cows. And one of the things that's that I found counterintuitive at first, although again, as you said, once I thought about it, it made sense, is that typically when farmers, or livestock farmers that is, begin to improve their soil through better grazing management, suddenly they have so much more grass growing. So what do? As I mentioned earlier, it's unhealthful for the grass not to be grazed. The grass has to be grazed. So these farmers end up bringing in more livestock to eat the additional grass, and then the soil gets healthier, and then more grass grows, and now you need more livestock. If you're in a part of the world where you have high enough rainfall, you could allow some of your land, your pasture, to go back into forest if you wanted to, but trees generally take about 20 inches of rain a year or more. And there are huge parts of the world that get less rain than that. So you're only going to have grasses that are growing. In the case of Alejandro Carrillo, the slides I showed from the Chihuahuan Desert, his carrying capacity, the number of animals on his land has gone up tenfold, his livestock. And he needs those additional animals to continue doing the restoration work. Just a couple of days ago, I listened to an interview of a distinguished professor from an Ivy League college in Hanover here, who again said, you know, people should eat less meat. And I'm like, well, how would that work? Like, I was speaking earlier to Avery about a rancher from Idaho, Glenn Elzinga, who's doing amazing work. The area where he grazes is 900 miles away from the Pacific Ocean. And there's a salmon run. I never knew salmon traveled almost 900 miles up a river. That was news to me, all right? But in recent years, recent decades, the salmon haven't been able to make the run all the way. And the reason is because there was so much soil erosion happening in the headwaters. The water was very turbid, you know, there was a lot of floating around in it, murky and so on. But by doing the proper grazing management, Glenn has been able to restore the soil in the headwaters. So now, not only is more water getting down the river, but it's cleaner now. So salmon have been able to he was very surprised one day to see the salmon had reappeared. They can now make the full 900-mile journey that they used to make historically. He could not do that if he had fewer animals. He needs the animal impact in order to achieve these ecological results.
So now I just thinking, I think the problem in the message that has been, well, at least I've been taught to give farmers is the reduction of the lifestyle. But the true message they need to hear is the soil health and understand that process, because I think now I'm actually learning about this is good, because now I realize that even though you may tell a farmer they may reduce their lifestyle, if they still aren't allowing the proper soil health, then they're still not going to be doing any good.
That's exactly right. Yes.
Yeah, it's a really good idea and sounds feasible, but I'm wondering, is there a tipping point? You know, so do we know how many animals, or have an idea of how many animals before it becomes unhealthy for this?
It would vary depending on the context. Everywhere in the world would be a different answer. And the only way that you can find out is actually by doing it. Let's see. So there is no, like sometimes people ask, you know, what's the ideal stocking rate or so on, you know, so I can go back to my farm and implement it. And it's really impossible to say, because it depends how healthy the soil is when you're starting. If your soil is already very healthy, then you might not notice a significant increase in livestock numbers. If the soil is really degraded, then you keep adding more and more livestock in until you reach the point where you notice the animals are not achieving the same daily weight gains that they used to before. And you think, okay, now I've got, you know, too many animals in my herd. You know, I'll sell off a few more this year. I won't run as many next year. If you go through a period of drought where rainfalls are abnormally low for a number of years, then typically you would have to scale back or destock during those times. And when the grass is better, the advantage of the soil being healthier is that it's more and more resilient. So droughts and floods will not affect you or the farmer to the same degree as it would with the degraded soil.
And it makes a lot of sense, but I just wonder the practicality of, you know, of having this, you know, kind of hit or miss. I'm just wondering about how practical it might be.
Yeah, and I would just add for clarity, because it took me a while to really understand what was being talked about here when I was first introduced to this concept, but what we're really talking about is increasing the stocking rate and decreasing your paddock sizes and increasing the amount of times you're moving. So some farmers, some crazy farmers will move their cows multiple times a day. You know, they'll be going out and you know, it's a different type of labor. It's not necessarily harder, it's kind of somewhat easier, but it's also, you know, it's tying you to your farm to be out there, you know, moving animals twice a day. But it's not to say that that's, you know, they're tied to their farm anyway, but it's a different type of labor that you're asking a farmer to do.
So is that why he meant in that video he said raise like some then wild is chasing.
As if it was wild, yeah, exactly.
Okay, so that.
So
means
that they're
like- So that
Dense,
they keep
and they
moving.
keep
So they would keep moving, they would stay the same.
and Katora's had her.
So, I understand that the cows are, trying to regenerate the microbiome and whatnot, for grass and all the organic matter and whatnot. But the only thing to think about is, if anyone knows anything about geography, when someone makes a map, oftentimes maker of the map has their own intentions of how they make the map and the scaling, and I do like the research behind this state doing similar things, because it's counterintuitive and odd to me, because you have to clear more land for more production of livestock, so that's already like, if we already said livestock have a bad use, I think, and only benefiting the areas for, the grass. But not structure or different monocrops, monocrops, crops. To feed these cattle, it's also, there's a lot of cons in this one code that we're trying to fortify livestock production, so I get that, let the meat sure, but at the same time, is the economy going to be willing to even take a step forward to have it should happen, talking about what this bird needs, it needs to kill out any elephant, any kill any bison, that was very odd to me to hear also, but what the bird actually needs is time to just regenerate itself, and it's not just it will break, like how Corona had us. I think it was research done when there was that settlement in the western end of the world, really, when we just kind of took a lot. Birds, I was talking about it, I already appeared in Marcel, but he was saying that he had read something that it was just, ecosystem was just working in a way that it had a chance to regenerate itself, so. We're talking about regeneration and what the earth needs, I don't think the economy has the capacity to do that, so it's not about if we can do it or not, it's just very natural, because that's just how the world is right now.
Okay. So in response, when you improve soil health, that's at the foundation of restoring the entire ecology of the system. At Alan Savory's place in Zimbabwe, it's become so fertile and so fecund that during times of droughts, the wildlife, the elephant, there's a scene of him walking with his elephant, not right there, but it was an elephant, the elephant's name was Dojiwe, which means found. It was an orphan elephant that Alan grew up with. Anyway, during times of drought, the wildlife, including the elephants, lions, and so on, they leave the national parks where they can't find any food or water, and they will come over to Alan Savory's ranch, where there is plentiful food and bountiful food. So it's not just about having cattle there, it's about restoring the ecosystem for all of the wildlife. When you manage a ranch well, the cows are only on about 1 or 2% of that ranch at any given time. The other 98% are available for the wildlife that lives there. And do we need to clear land for cows and for grazing? Well, there was a report by a researcher, Pimentel, I think 2013 or so, that said that right now worldwide, let me back up. The land area of the United States, coincidentally, is almost exactly 1 billion hectares or 2.5 billion acres. It just coincidentally. Worldwide, there were about 2 billion hectares. In other words, twice the land area of the United States that was formerly used for cropping, growing crops, that has become so degraded that it's been abandoned. So we've got 2 billion hectares of land around the world right now, just looking like desert, doing nothing, just sitting there. But that today we know how to bring it back. So I would say, let's heal this land, not cut down a rainforest, to grow soy and graze cattle. Let's go into these desertified lands. So that the fellow I showed in the Chihuahuan Desert, that land had basically been sitting there like desert for probably decades, if not centuries, because of improper grazing. But by doing the correct grazing now, He's restoring the land so that all of the animals, all of the wildlife can prosper. Again, it's not, the conversation is always seems to wrap around meat, and I see meat as a distraction. It really is about the soil. If we have healthy soil, then animals of all types and all species can thrive.
So Delilah is next.
I hope I answered your questions. Yeah. Happy to talk more if you'd like afterwards. Yes, please.
Could you touch a little bit on the theoretical framework of holistic management as it relates to environmental, social, and economic concerns? Because I know a little bit about it. I see his management style as surpassing a lot of different boundaries, like kind of like you said beginning when he confirmed the separation of discipline that was so common.
Yep.
And I am trying to bring his management style, and I would love to more people to know about it.
Happy to. So Alan Savory wrote a book called Holistic Management, which I read probably a dozen years ago. It's a pretty accessible work. Back in the 1970s, once Alan figured out how to do the grazing in a way that healed the land, at first he thought, okay, problem solved. But he very quickly realized that farming wasn't just about animal management. It also had to do with one's social spheres. You know, do you have a supportive family, a supportive community, or do you have elderly parents that you're taking care of, and so on. So the social element had to be included into your farm planning as well. It couldn't just be about the crops or about the animals. And he also realized that the financial component was also crucial. You can do all this great farming in the world, as much as you want, but if you're not making a profit, then you're not going to thrive and your business may likely fail. So holistic management, and I have to say, when I first heard the term holistic, I was like, oh geez, this sounds like new age, like new age music and crystal healing, and I'm not, there's nothing wrong with that stuff, because I think there's probably a lot more to it than we understand at this time. But nonetheless, I was skeptical. And then I began to learn about the history of holism. And there was a Dutch politician in the 1920s, Jan Smuts, who wrote a book called Holism. The word holism, holistic, comes from the word whole, W-H-O-L-E, thinking of things as wholes. And so he published this book on the theory of holism, in which he laid out this framework that everything is interconnected. And supposedly Einstein wrote Smuts a letter saying, I believe that in the future, the two theories that will offer the most relevance is my theory of relativity and your theory of holism, because it explains so much about nature and about human systems. So today, Alan, he doesn't even want to talk about grazing. He wants to talk about holistic management as a way of making decisions for policy, whether it's within a family, whether it's in a business, whether it's a government policy, but to bring together all of the stakeholders, everyone who has an active interest in it. And instead of, before you even get into the process of deciding, how are we going to do this or how are we going to do that, the process begins with setting a vision. What do you want for your children and grandchildren and great-grandchildren? What type of world? Do you want clean air, clean water, good food, nutritious food, security from droughts and floods and all these other, natural disasters and so on. And what he found time and time again, that when he brought together even warring factions, people across the political divide, if he could lead them through the process of envisioning what they want, it turned out everybody, regardless of their background, all wanted the same things. Once you begin to agree on the goals, your hopes and your visions for the future, then when you have suggestions, okay, let's do this or let's do that, you can test those against, well, does this help us meet our goal that we all agreed on? Is this going to be beneficial? Is it going to be destructive? And so by going through that in a very sort of methodical process, we can hopefully arrive at policies that will achieve the vision that we want. I hope that addresses it. So anyway, more question? Yes, sir.
I actually learned to rotationally graze on a Savory Institute farm, which was connected with the Institute and followed his practices. And so I have a lot of love for everything sort of he's brought to the agriculture world. And I'm very much a disciple of his teachings. I try to share it wherever I go. I think it's important also to recognize that his practices are practices that many cultures and nations, indigenous people have been using forever, since the advent of agriculture. We need to not ignore that aspect of it, and that sort of gets me to my question, which is, colonizers not only brought poor agricultural practices that degraded the land, but also invasive species, or non-natives, perhaps they're better called. And I know that those species have shorter roots and don't hold on to soil as well as some of the native species that they sort of move out of the area just by inhabiting it. So I'm wondering what your take is on sort of plant aspects of this process, not just bringing in the animals, but what about replacing the plants? I don't remember exactly where Alan Savory lands on that. I think he's somewhere in the middle rather than one side or the other. But I've always been curious about that more because it can't just be the animals, right? It also has to be what plants are there.
So in degraded soil all over the world, there are many plant seeds laying in what's called the seed bed, it's upper layers of the soil. In some cases, they could be even a century or more old, and the seeds will still be viable. They're just waiting for the right soil conditions to sprout and grow. So a common experience that many regenerative ranchers have is that several years after improving their grazing practices, they suddenly begin to notice all these different plants in the field that they didn't plant. Well, where'd they come from? And in many cases, seeds are being blown in by the wind or tracked in by animals, or like I said, just laying there, maybe for a century or longer. And many of them are the native plants. So as the soil gets healthier, the plant populations that are right for that region will begin to grow and proliferate. And in many cases, that's how, the invasive plants, if you will, in many cases weeds, or eventually they disappear over time because the environment for them is no longer as productive and as conducive. And I have been searching for quite a few years for research showing that indigenous peoples anywhere in the world learned how to manage animals in a way to restore degraded ecosystems. I've heard this claim before. I haven't seen the evidence. Certainly in North America, the native peoples coexisted with the bison, and they would do things like the breed bison jumps or bison kills, where in some cases, hundreds or thousands of animals were driven off cliffs so that several of them could be harvested for the meat and food and fur and leather and so forth. But the Native Americans were not using bison to restore degraded land. We see from, it was a 2017 paper by Jonathan Sanderman. It was related to the map that I showed of the degraded land all over the world. I don't know of any indigenous people, and they did do a lot of particularly cropping practices like companion planting, biochar, use of mulch and so forth that absolutely should be emulated. But I don't know any research showing that indigenous people did regenerative grazing, but I would love to see it if somebody has.
I would just say my thought that came to my mind was the llamas down in South America.
The what?
Llamas down in South America, maybe.
But maybe I'd love to see some
Research. I was like thinking of animals where they were directly, it's hillsides that were very steep, and adding llama dogs to that would be very important. Just theory, but yeah.
But I'd love to see it. I mean, in Ireland, for example, there have been shepherd and sheep herding operations, that have gone on for thousands of years. Ireland is a very high rainfall environment, and so it's not going to show the same loss in soil health as someplace, say, in the Middle East. There was a researcher who looked at. People might know just in general that the Egyptians used livestock. In fact, they worship the scarab, which is another name for the dung beetle. It was included in a lot of their jewelry. There are even these large statues. And where do you find dung beetles? You find it where there's dung. Where do you find dung? We have grazing animals. So Egypt at that time was incredibly fertile. And we know from scientific evidence that the Sahara has a certain cycle every, we got tens of 37,000 years or whatever it is, goes through wet periods and drier periods and wet periods and drier periods. But about 8,000 years ago, that area began in the Middle East began drying out and desertifying way off schedule. Like it should not have been happening at that time. And the question had always been why? You know, what were the factors that were causing this? And this researcher, last name Wright, I forget his first name, looked at early records, some of the oldest records that exist, 2,000 years old. And what he found out was that the patterns of human civilization, as civilization spread, sure enough, whenever the humans, the livestock herders arrived at that site, the land would begin to turn into desert. So he was able, we called it hopscotching, you know, for every place they went, sure enough, desertification followed in their way. Which to me is pretty strong evidence that those people who were managing the animals thousands of years ago did not know how to do it in a way to preserve their land. Because if they did know that, then they would have done that. And instead, the whole Middle East region was turned into a desert. You know, the Fertile Crescent. And one of the hopes, my hopes personally, is that we bring back fertility to the Fertile Crescent. And another point that I touched on, although I don't know, I'll say it more explicitly, a lot of people think, you know, the cows with the manure, that's how the carbon gets in the soil. Absolutely, some of it does. But the vast majority of the carbon that's going into the soil is being pumped in there by the plants. And not only that, each type of plant makes its own type of syrup that feeds a certain population of life in the soil. So if you want to have a lot of diversity in the soil, you need to have a lot of different types of plants pumping in these sugar solutions. And the plant doesn't just pump the same solution throughout its life. Early on, as a young plant, it's sending down sugar that's telling certain microbes in the soil, okay, I'm a baby plant, this is what I need you to produce. Okay, so it's feeding the microbes that will give the plant what it needs. Later, as the plant becomes more mature, at different points in its life cycle, goes through the seeding process, it's changing what its flow is into the ground in order for the soil microbes to give the plant what it needs. And there was a famous experiment done in Germany back in the 2010s, where at a research site, there were, I think, 60 different plots were laid out. The first plot had one type of plant in it, the second plot had two types, three types, all the way down the line until the very last plot had 60 different types of plants growing in there. And several years into the study, the local riverbank overflowed and this entire farm got flooded out. And a lot of research scientists were like, oh no, you know, we've lost all this research, we're gonna have to start over again, we're wasting money and resources and so on. But then when the floodwaters finally cleared, they looked at the field and they saw that the sites where there were only a few species of plants, it's true, they were lost. But the more and more species that you had growing there, the greater the survivability. Nature operates in diversity. When you have diversity, you can handle things like early droughts or early freezes, or any sort of environmental calamity that comes along. Having a greater diversity gives you more protection.
Okay, one other thing from that study, from what Dr. Christine Jones
Yes.
shared with us this summer, was that like a key finding was around 4 plant families, the families of the plant, not, the species, but the families was that trigger point. And then, it started to reach a point where you could have quorum sensing, where there's enough of the chemicals in the soil where the enzymes start to act differently. Like it turns on new gene reactions when you have a certain amount of, you meet a certain quorum.
Right. So if they have a cover crop with only 1 or 2 types of plants, for example, which is not uncommon, then in the soil, you might have the equivalent of the butcher, the baker, and the candlestick maker. But if you have a dozen plants now feeding the soil life, well, now you've got the nurse, you've got the doctor, you've got the plumber, you've got the electrician, and so the 4 groups would be the warm season grasses, cool season grasses, forbs, and legumes. So if you're going to plant a cover crop, and if you want to see much faster results, you want to have as many different types of plants as possible, seed them all at once, and that's the way the soil life will be switched on much faster.
I saw two hands. Are there two more questions? Are there any more questions?
I had a quick question.
Okay.
Sorry. Like in our territory, we have a extremely high level of food that goes to waste. On our fruit trees, we don't have any processing or anything. I know that adds carbon to the soil on some level, but isn't there something that there's a lot of greenhouse gases and impacts the environment in a negative perspective because of the high amount of rotting fruit? Can you speak to that briefly?
The rotting fruit will produce methane. That's true. So it's better if it can be eaten or even turned into biochar, if that's an option. In general, I used to think that the way new soil was formed was when all the leaves fell off the trees and then they decompose, and then the carbon from the decomposing leaves goes in the soil. And I learned, historians certainly call this, that's not the case. When plants rot on the surface, almost all of the carbon dioxide and the methane, ultimately, goes back up into the atmosphere. So again, the way the carbon gets in the soil is with the plants, with the root X states pushing it in. Mostly what happens at the surface will be ultimately oxidized by the sun. If you can keep the surface covered using compost or mulch, then that prevents the ultraviolet rays from breaking up the organic molecules on the surface of the soil. So you can absolutely prevent erosion and improve soil health. And the mulch, for example, will provide food for the microbes to eat and so forth. So it's even if all the compost gets eaten up, and the carbon goes back into the air, you're still creating more carbon in the soil because you're allowing the plants to do their job. Yes, please.
Next one. So, yeah, I'm all for building soil and permafrost and sequestration, and there's a lot of different words used for regenerative or holistic management and pathways, and yeah, I see such importance in this, and thank you for presenting. I think I am feeling urged to speak to something that I see that this narrative is maybe blocking on like the cultural, geopolitical scale, a focus on solutions. And while it needs to be like farmer centered and land people centered, I think the framing of as a solution and sense of urgency and like a path they're thinking in just one right way, those are some of many characteristics of white supremacy. And what is really emitting of military and war and industrialized colonialism, I think it can be distracting or like not what I think the government can be spending money a lot differently than it is now, and I agree with all of these practices, but what was coming up for me from hearing it.
I agree. I mean, there's a ton of greenwashing associated with meat production, because there are many meat spokespeople who will say, "Oh, beef isn't causing a problem," and that's a lie. And there are others who say, all meat production is inherently harmful, and that's not true either. So I think that there's a middle ground or a third path, which is using animals in a way that helps nature, which neither side is even acknowledging. The greenwashing and the takeover of the term regenerative agriculture is really pretty painful as somebody who promotes it. Part of the problem is organic does have a legal definition, regenerative doesn't. So pretty much anything can be labeled regenerative regardless. I mean, there are a lot of farmers today that are using cover crops, which is a good thing, but then they're using herbicides like glyphosate, Roundup, to burn the crops down, to get rid of them. So they're killing the soil and making food less healthy or harmful, because of the chemical agents that are being used. Thankfully, I'm honored to know now regenerative farmers that haven't used any fertilizer for 15 years because the soil has become so healthy, they no longer need to. That's, I think, what ultimately is going to send the message. But I would agree with everything that you just said. It needs to be farmer centered. Solutions are going to be different everywhere around the world. The reason I talk about grazing so much is that 2/3 of all agricultural land around the world is used for grazing. In many cases, typically it's because the rainfall is so low, nothing else will grow there. You can have a healthy grassland and as little as 4 inches of rain a year. Whereas most crops require 20, 30, 40 inches of rain, or, require irrigation and so on. So anyway, we've got this massive amount of grass and land around the world that has to be grazed, otherwise it's going to turn into desert. So we need to figure out the grazing part of the equation in order for regenerative agriculture to work. Now, on the cropping side, there are countless solutions. Many of them do date back to indigenous practices that I mentioned. Farmers are coming out with new approaches all the time, like some of the ones I showed, like planting crops right into your cover crop mix, for example, which is a way of disturbing the soil as little as possible. But it's all about context, and maybe this is a good point.
Yeah, and I don't, like, Greg, you kind of keep going like this.
Yeah,
I'm like, do you have one thing and then
Okay,
if we get with Carl, I know you do too. I mean, it
you
would
want
be,
to ask one more question, or?
yeah, and Zabi, we
I know it's
have.
not quite the topic.
Sure.
You mentioned research. Side of the indigenous people.
Yes.
I think the indigenous people kind of live within the ecosystem. So there is no need for any regenerative work. Maybe.
And Carl, we'll hear, I'm sorry, ending there.
But I was just wondering if that might be the reason why there isn't any research.
Yeah.
On their behalf.
Right.
What-
And
yeah.
maybe Zabi can also share what she wanted to say and then we can hear final reflections.
It's not on.
Yeah, no, but it's fine.
Well, and then just to hear final reflection from Carl and then we got to wrap. You can
Okay.
add to it, yeah.
Friends Farm, we were talking with, not the name, but she was talking about macro scale. And keep them in your area rather than adding. I don't know all too much about the implications of adding foreign microorganisms, such a thing. I don't know.
My understanding is that it probably inoculating like mycorrhizal into a soil microbiome. And one of the things Christine Jones I learned from this summer is that each seed has approximately 9 billion microbes in it.
On it.
Bacteria and fungi on the surface of it, excuse me.
Yeah.
So each seed comes kind of complete with its entire microbiome,
Mhm.
and
And it gets it from its mother.
it gets it from its mother. As all word. So basically what we're trying time will be what the ecology decides is appropriate for that. So I'm a little, I'm not convinced that adding, inoculating with types of certain, I mean, possibly in some situations it could help. But my understanding is the jury is still out on that. And just to respond to your question too, the research shows that for thousands of years, land around the world, has been degraded. So there absolutely are many examples. I know in Latin America, for example, there were civilizations that were able to be kept going for thousands of years by using different practices like the companion planting and the cover cropping and mulching and so forth. So yes, and I think that also had to do with the rainfall patterns like as well. In areas that were seasonal rainfall and low rainfall, there are no cases that I know of historically that were then brought back. And land will come back on its own in places like New England, but places like Arizona, when you destroy the land, it's not going to come back until you reintroduce the ruminant. You have to have the grazing animals there to kickstart the process. In some cases, if the land gets healthy enough and the ecosystem is healthy enough, and if the wildlife populations have been able to build back up, by all means, pull the cows out and let the wildlife thrive. If you can get the ecosystem that healthy again, sure.
Thank you so much, Carl. I checked the conference, you can join anytime between 8 AM and 8:55. Right, so we're all gonna get there before 9 AM. I still don't have the room. They don't have it on their website. They're not as well organized as us. And then,
Better guess.
yep, you could also go to the cafeteria and grab food. Either one, I'm sure they'll have some food, but we've got food in the cafeteria. You might have better options. I don't think it's gonna be a full breakfast, so it'll be continental breakfast. So up to you. So we'll see you in the morning. If anyone wants to set up a table with us, that's on my meeting.
I just remembered I was supposed to end with a poem, because I'm a climate and soil poet also. It's short. It's called Climate Future on Climate Farming by Karl Thidemann. So what's the future? Is there no hope? Healing the land can help us cope and grow better food with less flooding too. The carbon in soil is what we must do. Draw down the heat, slow the sea rise, let birds and bees thrive in the skies. Good farming is how we deal with this mess. Now the climate's fixed, what's next to address?
Yeah, I just wanted to say I enjoyed that very much.
Thank you. What's your name?
Ayana Simon. I'm from Virgin Islands. I work with the veterinary certification